In this video, we're going to be looking at a key part of the research methods topic, which is reliability. So this is the specification. This is what you need to know about reliability. Reliability across all methods of investigation. So we're going to be looking at where reliability is relevant to self-reports like questionnaires and interviews, as well as relevance to observations and experiments as well. And then there are different ways of assessing reliability. This word assessing, you might also see checking or measuring. They all relate to assessing the reliability of a particular measure. Specifically, we're going to be looking at split half technique, test retest, and inter-observer reliability. We'll also look at the end of this video at ways of improving reliability too. So what do we actually mean by reliability? Reliability is a measure of consistency. This is our key term. Reliability is about consistency. It's the extent to which a test or a measure produces consistent results. What we mean here is, for example, a particular questionnaire like the F-scale. Does it produce consistent results? Does it measure the same thing over time? If something is consistent, if a measure is consistent, the F-scale, for example, it means that if you give the participant the F-scale on Monday, they should get the same results when they conduct the F-scale on a Thursday. If it's consistent, it's producing the same results over time. We're going to be looking at internal and external reliability. And I'm just going to use the analogy of a ruler to just illustrate this. So here we have a ruler. If we're talking about internal consistency or internal reliability, what we really mean is that within the measure itself, are all of the different items consistent? So for example, with a ruler, is the gap between 2 centimeters and 3 centimeters the same as the gap between here, 4 and 5? And so on. Okay. So we're talking about within the measure itself, is there consistency? In terms of a questionnaire, do all of the items within that questionnaire all measure the exact same construct? Are they all consistent in what they're measuring? So if our questionnaire is trying to measure depression, do all of the different items within that questionnaire all equally measure depression? Or does some measure, for example, attitudes towards God? So we want to make sure that they're all consistent in what they're measuring. That's internal consistency. External reliability, this is the consistency of the measure over time. So from time 1 to time 2, if there is reliability within our questionnaire, participants should get the same results at time 1 and time 2. We shouldn't see any changes. So reliability is really about the consistency, either within the measure itself, so items on a questionnaire should be consistently measuring the same thing, or we're talking about consistency over time. If participants are completing the scale at different points in time, they should get the same results. So let's have a look then at different ways of actually measuring the reliability. Let's start with the split half technique. All of these, the clue is in the name. So if you're not sure, just think about what split half might refer to. This is a technique that we use when we're looking at particular tests or questionnaires, when we're looking at self-reports of that nature. And this is a measure of internal validity. Remember, this is about then the consistency within the measure itself, within the questionnaire in this case. Do all items of that questionnaire equally measure the same construct? So how do we do this? Well, for each of these reliability questions, they are always going to be 4 marks. So it's really important that you're able to explain each step in that reliability assessing process. The first thing is that we need to take our questionnaire and we need to split it in half, hence the split half technique. So if our questionnaire has 10 questions, then we want to take questions 1 and 5 and 6 to 10. There, we've split our questionnaire in half. What we then want to do is ask the same participants to complete both halves. So our 10 participants are going to complete questions 1 to 5, and they're also going to complete questions 6 to 10. Then we want to correlate our scores. A quick note on correlations. Let's pause there actually and just go back for a second. A correlation is where we're looking at the relationship between two covariables. So we might be looking at the relationship between hours spent revising and the percentage that you get on the exam. Here is covariable 1, here is covariable 2. And we're looking at the association or the relationship between those two covariables. There are differences between correlations and associations, but more on that much later on in the course. If there is a perfect correlation, so for every hour spent revising, you have a, for example, 10% increase in your exam score. A perfect correlation, as one variable increases, the other increases proportionately. A perfect correlation gives us a correlation coefficient of 1. So if there is a perfect relationship between covariable 1 and covariable 2, we have a correlation coefficient of 1. If we look at two different covariables now, let's say house number and IQ, and we plot that on a scattergram, we are unlikely to see any relationship between those two covariables because there wouldn't be. In that case, our correlation coefficient would be 0. There is absolutely no relationship between house number and IQ. So here we've got a perfect correlation coefficient of 1, and here we've got no correlation, 0. So let's return then to look at the split half technique. We've split our questionnaire in half, and we've given participants both halves to do. Now we want to correlate their scores. What this means is that we're going to correlate their score from questions 1 to 5 and questions 6 to 10. And we're going to do a correlation coefficient. We are looking for a correlation coefficient of plus 0.8. We want it to be a positive correlation of 0.8. Remember, 1 is perfect. 0.8 is a strong correlation. If there is a correlation coefficient of 0.8 or greater, that means that there is consistency between each half of that questionnaire. It means that there is strong reliability within that questionnaire. In other words, its internal reliability is strong. So they're the 4 steps for calculating the split half technique. We split the questionnaire in half. We give the same participants both halves. We correlate their scores on those two halves. And we're looking for a correlation coefficient of plus 0.8 or higher. If it is, then fantastic. Our measure has internal reliability. If not, then we're going to need to go back to the drawing board. We might want to change some of the items to make sure that they are all equally consistent in measuring the construct we're trying to measure. This technique is really good at detecting ambiguous questionnaire items. When a question is ambiguous, for example, there was one we came across in the F scale, wasn't there? Familiarity breeds contempt was our example. That's quite ambiguous. And that means that there's going to be lots of variability in participants' responses. It's more unpredictable because different respondents are going to interpret that question very, very differently. So we're going to have quite erratic responses. So if it's a scale, we're going to have some people way up here, some people way down there, and they're going to be quite unpredictable. Split half technique is really good because when we split the questionnaire into halves, if those ambiguous items are not equally distributed across the two halves. So for example, sorry, the animations aren't working very well with the annotations. If there are a couple of ambiguous items here, but not here, then that's going to reveal itself in the split half technique. It means that we're going to result in a really low correlation. It means there's going to be less of a relationship between these two halves of the questionnaire. Participants' score on this half is going to be quite different to their score on this half. So that's going to reveal itself in the split half technique. And that's going to result in a low correlation. So doing this can be really useful if we want to know if our questionnaire has any ambiguous items. Okay, so that's a split half technique. Let's have a look then at test-retest reliability. This is a measure of external reliability. So this is about the consistency of a measure from one use to another. In this case, what we're trying to do is to see if there is reliability between the first time participants do the test and the second time they do the test. Test, retest. Time 1, time 2. If our test is reliable, it should produce the same results on separate occasions. So these are our steps. We want to give the same participants the same test on 2 separate occasions. To get your full marks here, time 1 and time 2. So this week and then again next week, for example. Again, then we want to perform a correlation. We want to do a correlational analysis, and we want to basically compare the scores from time 1 and time 2. We're going to correlate those scores. And again, we're looking for a correlation coefficient of 0.8 or greater. If we get a correlation coefficient of 0.8 or greater, fantastic. Our test has test-retest reliability. If not, then we're going to need to make some changes. So for our 4 marks there, same participants get the same test on 2 separate occasions, time 1 and time 2. We correlate the scores from time 1 and time 2, and we're looking for that correlation coefficient of 0.8 or greater. It's really important when we're doing test-retest that we time the interval between those 2 tests wisely, right? If we don't have sufficient time, so if we do them back to back within half an hour, for example, they're going to remember their responses and they're just going to respond in the exact same way that they did last time. And that's not really going to test the consistency from time 1 to time 2. So we want to leave a sufficient gap. But if we leave it too long, if we leave it years, then their responses might have changed. But that's not because the test isn't reliable, that's just because their attitudes have. So we want to make sure that we find that sweet spot between it, and when we're looking at that interval between time 1 and time 2. Okay, and then finally, our last measure of reliability is inter-observer reliability. What we're really asking ourselves here is, when conducting an observation, are the 2 observers viewing and rating behaviour in the same way? Or are they showing some bias and subjectivity? Is there observer bias? So when conducting an observation, the observers will create categories for their behaviours. So for example, if I'm observing children in the playground, I'm going to create categories of behaviours that I expect to be able to observe. So it might be, for example, running in the playground. It might be talking. It might be playing with a football. It might be sitting with friends. They're my behaviour categories or behavioural categories. We want to know, are our observers interpreting those behavioral categories in the same way? Is what I'm classifying as running the same as what you're classifying as running? Or is there maybe a mix-up between whether somebody's playing football or whether they're running? Because those two things might look very, very similar. So this is what we want to do. Our 4 steps for calculating inter-observer reliability. Our first step is to ensure that we have 2 observers observing the same behavior at the same time. That's our first step. We want to make sure, in fact, let's do that step 2. We want to make sure that our observers agree on the behavioral categories. Which means they might have a discussion beforehand where they will say, let's count that as running, but if they're doing this, we don't count that as running. And they have a discussion and they agree on those behavioral categories. Then we want to make sure that those 2 observers are observing the same people, the same behaviors at the same time, but independently. We wouldn't want them to observe together and to discuss what they're seeing together, because then we only have one set of scores and that won't allow us to correlate. We need to have the scores from observer 1 and we need to have different scores from observer 2 so that we can perform that correlational analysis. So they need to be independent so that we have separate sets of scores for each person. Then, once again, we want to calculate the correlation coefficient between those 2 observers' scores. And we're looking, once again, at a correlation coefficient of 0.8 or higher. That would tell us that there is consistency between observer 1 and observer 2. It means basically they're agreeing on the frequency of those behaviours occurring. If not, then maybe we want to redefine our behavioural categories. Maybe we need to specify what they are a little bit more clearly. And we do this when we conduct a pilot study. You'll learn more about pilot studies later in the course, but basically we do a dummy run. We do a test run before we actually gather our real participants. So we do a small scale trial run of the actual investigation. All right, so the key phrase that you're going to hear us say over and over and over again, it ain't great if it ain't 0.8. For all of these measures of reliability, we're looking for a correlation coefficient of plus 0.8 or greater. If we get that magical figure, then it means that our measure is reliable and we can claim reliability. So then the next question is, how can we improve reliability? Before we were looking at how we assess it or measure it or check it, but you could also get asked questions about how we might improve reliability as well. Now, it really depends on what you're being asked to improve. If it's an experiment where we've got an independent variable and we're measuring the influence on the dependent variable, then there are some certain things that we can put in place. Some very, very common ones would be to standardize our instructions and procedures. This means that we want to ensure all participants experience the study in the exact same way. They're all given the exact same instructions. They're given the same equipment. They're completing the task in the same environment. Every single person is experiencing that study in the exact same way. That's going to improve the consistency of our study. We also want to operationalize our variables. We want to clearly define our IV and our DV. For example, if I'm measuring, if our dependent variable, for example, is attention, well, that's quite vague. And it might mean that the results then are inconsistent because our way of measuring attention might differ. So we want to make sure that we've got a really, really clear way of measuring attention. For example, it could be the number of tasks completed in 60 minutes, for example. So if we're able to collect objective data data that's typically numerical and quantitative rather than subjective data, something that might be based on observation or opinion, then that's going to yield more reliable results. In terms of observations, well, we want to start with our clearly operationalized behavioral categories. We want to make sure that they are really defined. We want to make sure that there's no overlap. So before we had football and running, there's overlap there, and that's going to lead to low reliability. We want to make sure that all of the behaviors that we're going to expect are accounted for and that we can record them. Otherwise, again, that could lead to some behaviors being missed, some behaviors being recorded incorrectly, and so on. And we want to train our observers. We want to make sure that they agree on those behavioral categories even before we begin our observation. Here we might want to do a pilot study to check that those behavioral categories are actually are going to be sufficient for our observation. For a questionnaire, we could do a pilot study here as well. We could give our questionnaire to a few people and see if they think that it's, and just see what the results are. We could do our split half technique to check it. We want to use clear and ambiguous wording. We want to make sure that there's nothing there that could be misinterpreted or nothing there that is open too much to interpretation. We might want to use reverse score items. That could help as well. We might want to have more than one item. You know, if we've just got one question, it's going to be pretty obvious what the study is testing, and that might lead to unreliable results and so on. But we just want to really focus on the wording of those items. We want to make sure that each item is asking just one thing at a time, and so on. And then for interviews, lots of similar things. We might, again, want to do a pilot. We might want to do a structured interview. So rather than asking questions in response to the participants' responses, we want to have set questions for everybody that we ask. We, again, might want to train our interviewers and make sure that they're asking questions in the same way and that it's as standardized and consistent as possible. We might want to record the interviews, and that way we can go back and we can code the responses a little bit more clearly. And we might want to build rapport with our interviewees. And that way, if they're feeling comfortable, then it might reduce some variability due to anxiety or discomfort or whatever it may be. So this isn't an exhaustive list. This is just some ideas to get you thinking. But always, always, always with these types of questions, how would you improve the reliability? It's going to depend on the study. And you need to use your knowledge to actually apply to that specific scenario. So these on their own wouldn't be very creditworthy. You need to make sure that it's all really, really linked to the actual study in question. Okay, so there are some questions for you to do. Don't peek at the answers or the mark schemes. Just one final point is that we can have a reliable measure, but it could still lack validity. These are two terms that we use a lot in psychology, and they mean different things. Yes, they're related, but they mean really, really different things. So I want to illustrate this with an analogy. Obviously, you wouldn't talk about this in a response, but this can be just a useful analogy just to get you thinking about the difference between reliability and validity. If we take a target and a bullseye, a measure can be reliable but not valid. When we're talking about reliability, remember we're talking about consistency. When we're talking about validity, we're referring to accuracy. So here we have a measure that's reliable. It's consistently getting the same results, but it's not accurate. So here we've got reliability, but not validity. We might have a measure that is both reliable and accurate. So it's consistent and it's getting the same results. So it's getting the same results each time, so it's consistent, and it is actually measuring what we intend to measure. It's valid. Or we might have a measure that is neither. It's unreliable and it's not valid. We don't say invalid, we say not valid. So it's not accurately measuring what we want it to measure, and it's not consistently producing the same results. So this will obviously all fit together a bit more as we look at validity in a little bit more detail as well in future weeks. But hopefully for now, that's given you a little bit of a taste for how we assess reliability, and also how we might improve reliability.